Prince has given me. By the way, Prince, I'm very grateful for this opportunity. Thank you, sir. I would like to know if you can please show me with a show of hands if you have ever written one line of code. So no, the software guys are here. Lovely. All right, that's fantastic. So if I was to use the phrase "hello world," you know what I mean? What is hello world? No, don't worry, I was going to. For those that don't understand, hello world is the first line of code you write when you're about to learn a programming language. It's how you know whether that thing, it works. Are we together? So today we're going on the hello world tour. Are we together? So we're going on the hello world tour because we're looking at principles. And I need you to understand something as I'm about to give this talk. Like, please don't look at what I'm about to share and say, these are for people that are over there or people that are, no. I'm just like you. I grew up in Ikeja. So you understand me? So if I can give this talk, you too can. Are we together? Yes. So please don't let all the words I'm going to use, don't let it bamboozle you at all. It is just English. There's nothing that you cannot crack. Are we together? Okay, so please let's go to the next slide. We're looking at principles. We're looking at the principles to writing code. Principles to software development. And here I have 4 very basic principles that are very important that we take into consideration if you ever envisage yourself to be a proficient software developer. And before I go too far, I need you to understand something. Software development is not just for people that write code, but we'll come back and talk about that later. So please don't zone out and say, oh, maybe this is for those guys that write code. No. It takes a lot to develop software. But for whatever part that anybody is doing, the most important thing is to understand the foundation. I'm a Christian, and I'm sure some of us are here. So you would forgive me if I was to quote scripture. The Bible says, when the foundation is faulty. Thank you very much. So, the foundation is mostly critical. And you see, with the foundation is really understanding the fundamentals. For those of us that raise their hand that say they can write code, now I need you to answer this question for yourself. If I was to ask you, what is a computer? What would you tell me? Please don't tell me about monitors and keyboard, because that's not a computer. That's a peripheral. Are we together? So if I was to ask you what is a computer, what I expect to hear from you is you be talking to me about CPU, registries, RAM, ALUs. If you are not thinking in that capacity, then you have not started. Are we together? Because you see, no matter what code you write, no matter what language you use, everything runs on what? The CPU. So if you don't know how a CPU works, you might be writing code, but your code might not be efficient. It might not perform very well. And that's when people start saying, but this thing is so difficult, it's so difficult. It's not difficult. It's because you have not understood the fundamentals. Now, if you don't understand how does one computer talk to the other one, what are the protocols? How do they communicate? I'm sure you've heard of handshaking. Yes. And I'm not talking about when you shake somebody's hand. When 2 computers want to talk, the first computer will say, hello, are you there? The other guy will go, oh, I'm here. Then they will start sending messages and say, I'm about to send you this data, and I'm going to send you this amount of data. The other guy will say, hey, okay, I will create the space for it. and say, you can send it. Then the guy will start sending it. 1, 2, 3. The guy will say, you got 1, I got 1. You got 2, I got 2. You see the way we're talking? This is the fundamentals. Now, if you don't understand all of these protocols, then you struggle. And that's why a lot of people say software is difficult. No, it is not difficult. You know, I see my job. I'm playing games. I'm just solving puzzles every day. That's all I'm doing. Because I understand these fundamentals. So if you don't understand these fundamentals, please, I beg you, go back. Learn what is a CPU. Learn the protocols. How the computer talk. Learn about queues, stacks. All of these things I'm saying, I hope you are taking notes. Yeah? These are the things you need to understand. Because once you understand this, then you can go to the next point. You can adapt. Adaptability becomes a thing. Because now you understand how everything works. So the way you want it to work, you can adapt it. And you see, the thing with software is that, you see, software is not something that one industry uses. Software is something that every industry uses. There's no industry now that is not software. No industry. Even law. People are building genetic Gen AI for law. So that when you want to build a case in law, you just tell your chat GPT, say, you know what are the cases relating to this? And the machine will go and it will give you all of the things. What lawyers used to spend hours doing, they do now in minutes. That's law. I'm using that because we have just heard our great professor talk to us about law. And you might think, what has software got to do with law? Marketing, advertising, arts. There's no industry that's not software. Which is why we have to join this momentum that has started. We cannot be left out. Are we together? We cannot be left out. But it's all about understanding the fundamentals. It's all about understanding the adaptability. Because once you understand, you can adapt it to whatever you want to adapt it for. And what do you adapt it to do? You adapt it to solve problems. You adapt it for the problem. You know, I just talked about something in law. That's a problem, isn't it? I'm sure if you speak to professor and you ask him, when you get a case, how long does it take for you to build all the past cases and understand the thing? He will tell you how much effort it takes. But now, in a matter of seconds, 3 months research is done. That's the problem solved. Are we together? I'm sure you all heard of Flutterwave. What problem did you solve? Payments. Now, it was so difficult for us to do payments. I mean, payments, who hasn't been paying stuff for stuff? We've been paying. But it was very difficult. Yeah? But now, they came in, Flutterwave came in, they solved that problem. They adapted that fundamental issues fundamental principles they were talking about. They adapted to solve a problem. Now that they solved the problem, when I saw that their Series D funding, you don't know how much joy I had in my heart. I said, finally, because I know this will give people the right way of understanding how profitable this is. Are we together? Because what? It now leads to what? Employability. It makes you employable. You know, there's some, give you just share some experience with you. I remember there was a job I applied for. I'm from the UK, by the way. And I remember applying for this job, and they interviewed me 4 times. No one would have been 2 times. Why? One of the directors said, we can't let you go. We know we need you. But some people here don't want you. So, but because of the skill that I possess, even though some people didn't want me, we need you. So they kept bringing me back. to try to get everybody's buying. Why? Because I had something that they needed. Are we together? And it's really about understanding these fundamentals, understanding how to adapt it, understanding how to use it to solve problems. Now you become employable. That even when people don't like you, they still have to work with you, they still have to pay you. Are we together? Now this is just at the surface. This next slide. Because understanding that, we're doing Hello World. Are we together? I hope I still have your attention. Because we've talked about that, but you see, when you understand all of this, now how do we run this process? Because it's not just about writing code. How do we make this thing? How do we build it? What are the processes that we build? We use Agile. You see, if you don't know Agile, you need to know Agile. And those that, I'm not sure, some of us, have you ever heard the word waterfall? Please, if you've heard waterfall, please let me see your hand. I just want to know who I'm speaking to. You know waterfall? Waterfall was the process that we used before. You need to define everything beforehand. Then you build it. And at the end, once you build it, then you now present it. Then you realize that apparently what you wanted to, what the person that says you should build something for them is not actually what you built. You have taken it one direction because our people, things change in interpretation. We solve this problem by applying Agile. Agile means that what we do is we break that problem, we break it into small chunks. Then we run sprints, we run iterative sprints. And by running iterative sprints, what does that allow us? It allows us to be able to flexibly put it in scope. We're just going to do this now for the next 2 weeks. We focus on that. Okay, we know that we have this big mountain that we want to build, but forget about that. It's like when you swallow. Are we together? When you have a big mountain of pandemia before you, you don't just take everything and put it. What do? You put it, you break it into something you can swallow. Right? We do the same thing with software. We scope it, then we run the iterative sprints. By running these iterative sprints, we are able to build just enough. And then we use that sprint to collaborate with the customer. So we then engage with the customer and see, are we doing what you want? And if we see that we are doing what you want, then, because what happens is in this case is that ideas beget ideas. Then you do the first sprint, you go and the person goes, actually, the way you have it is not what I really want. Actually, okay, I know this is what I told you I wanted, but you know what, after seeing it like this, can we do it like that? Then you are actually able to solve the problem. So we use Agile. Next slide, please. Anything that we are building has frameworks that it uses. And one of the key frameworks is that you want to make sure that your code is clean. I'm not talking about cleaning your house. I'm not talking about using... When we talk about clean code, we're talking about when you write code that are simple. I know a lot of developers like to write code that are complicated so they can show that they have skill. It doesn't go with software, Hello World that we're doing. Why? Because you see, that code that you write, that code will still be in existence 10 years from now. If you write something that is spaghetti and complicated, 10 years from now, you yourself that wrote the code, you'll be scratching away when you read it like, what did I do here again? So why do we write it simple? Simple code. We apply frameworks that allows us to do things that are loosely coupled. You break it down, you use clean architecture, modular architecture, you break it into small chunks. Are we together? And then that way, when something happens in the future, you know where to go, you know how to fix it. So we use clean code and we have maintainable architecture. These are key areas for us to build software that are durable. Things that can stand the test of time. Because you see, the reason why we call this technology soft, there's a reason why we call it soft. Somebody's going to come and talk to you about art in a minute. But right now we're in the soft world. The reason why we call it soft is because it is flexible. Yeah? And soft. And why is it flexible? Because it can respond better to change. Because the only thing that is constant is change. Yeah? Change in government policies, change in technology, change in protocol. So you want to make sure that you use good architectures and you write clean code. Because as things change, you can change with it. You know, like when we started, when I started, I'm over 25 years in the game. When I started, we used to write what we call God classes, monolithic applications. You have a class that is about 2,000 lines of code. And then somebody will now come and join the company 2 years later and say, go and fix this bug. And the person is looking at 2,000 lines, where do I start? Yeah? But guess what? We have changed. We evolved from monolithic to microservice architectures. Microservice architectures allow us to use Docker. Now, who here thinks Docker is current? Who here thinks Docker is a current technology? Nobody wants to raise their hand. You know it's a cheap question. By the way, Docker is now old technology. Do you know that? Docker is now yesterday's tech. Docker is now 80s. It's old school. What's new school? Serverless. If you have not started engaging with serverless, please make sure you start to get yourself ready. Serverless is the next thing. That's the next kid on the block. Yeah? Serverless architectures, I would say if you're going to start with AWS. All the other cloud providers provide the same thing. Azure does it, Google does it, but AWS is the king. Yeah? Serverless is the new kid on the block. And it's making our work easy. Which is why we need to write clean code with maintainable architecture. Please, next slide. How do we, because you see, when we are writing code, we are building something. It's like when we go to a factory where they are building cars, right? They have a pipeline. Somebody here will put the engine, this person will put the door, that person will put the tire, and then they say the car is done. We do the same thing with software. We have what is called CI/CD, continuous integration, continuous deployment. Please, if you are not engaging with this, you need to engage with this. This is how we know the difference between a junior, mid-level developer and a senior developer. If you say you're a senior developer, you don't know CI/CD, that tells me you're not there yet. CI/CD is the means by which we build applications, we use tools to make sure that everything as we are building it, as you are writing your code, you commit it, it's building itself. As it's building itself, it's testing. Why do we test? Because we always make mistakes. We don't stop ourselves because we are human beings, we make mistakes. So we put things in place that help us to catch those errors. And so CI/CD is something that is very critical for how we productionize code. So we get automated builds from it, and it helps us to deploy that solution into where it becomes usable by the user. And this way we are able to manage and maintain and keep an eye on it, monitor what we are doing. So CI/CD is the means by which you productionize code development. Next slide, please. Now, errors, bugs. By the way, I hope you know the history of this word, why we call these bugs. It was actually a bug when the days when they used to have big mainframe computers. A bug, one of those butterflies entered into it, and the thing started misbehaving. So they went in and they found out there was a bug in it. And that's the origin of the word bugs. You cannot run away from bugs. Bugs is like natural things of life. It's like, okay, let's say it's like going to the toilet. If you don't go to the toilet for two days, or for 2 weeks, what will happen? You call the doctor, isn't it? But you know, I'm talking about something like that. Why are you talking about toilets? Yes. Bugs is like that. It will always be there. That's why we have toilets that flush, isn't it? So, same thing with software. We need to be able to manage bugs. And this is also where writing clean code comes in. Because you're going to have bugs. You have the right intention, but you know, a lot of times when you're writing code, you get so So your views are you want this thing to work, but then you forget that what if this other thing happens? Yeah? And that's why we have to be able to understand the problem when bugs happen, reproduce the bugs, so you can see exactly what is happening, because it's code. Computer does exactly what you tell it to do. It doesn't do anything otherwise. So once you can reproduce it, you can investigate it in your code base, and then you can put solutions in place. So when you're writing your code, you always put logs in it, because you always preempt that there will be bugs. Don't say, I'm a super developer, I don't write code. My code doesn't have bugs. That's the fallacy. Next slide, please. So let's talk about software teams. I'll soon be rounding up. Because you see, I've talked about software production, how to develop software, the basic principles. But you see, to actually develop software, you need a team. You need a team. And in that team, one of the key things that we want to make sure that the team can do is they must be able to collaborate. The teams must work together. And nowadays, there's a movement that they're talking about now. All the big industries, they came together, they understood they came to an understanding that they have to have diversity in their teams. Why? Because if you have the same group of people writing code, they will only write the code based on their scope of understanding. So industries in Google are doing this, all the big software developers are doing this. You want to make sure that there's female representation in there, there are people of diverse backgrounds that are there, because you have to have diversity of thoughts. So it's a collaboration effort. Yeah. So if you want to enter this game, you must be a team player. And you must know how to work within teams. And people have different personalities, which is not the problem. We just need to know how to manage it. Are we together? Yeah. So we have collaboration, and then you need to engage in what is continuous improvement. You need to make sure that you're always improving. I just gave you a narration of the changes in the technology world that is going on right now. Okay, serverless is already here. If you ask me to develop anything for you right now, I'll tell you, is it going to be in the cloud? If you say no, I'll tell you bye-bye. Why should I go through the pain? Because what we used to do before was painful. Now, I just put it in the cloud. Why? Because I don't need to monitor it anymore. AWS will monitor it for me. If your user base goes from 100,000 people to 1 million in about 2 weeks, I will not lose sleep over it. It will scale by itself. But if I was using Docker, and that happens to me, voila, this is when I'll use Are we together? So continuous improvement. You need to always continue to improve yourself. And we need to understand that when we are working together as a team, not everybody's going to be at the same level. So we need to have a shared achievement. Whenever we get something done, all of us need to celebrate. We should see it as a unit. And we should have that means by which we share the achievement. So even though you might have people in your team that are not so strong, don't look down on them. You need them there, the diversity of thoughts. And then you make sure that they share the glory as well. Are we together? Please, next slide. I'm just going to round up quickly, and I'm just going to talk about like different players in the team. Because you have different skills that we need. I'm just going to touch on them. I'm sure most of these are self-explanatory. So you need a UI UX designer. You need somebody whose focus is on how does it look? How would the user engage with your application that you're building? You need a software engineer, software developer. These are the ones that write the code. They're the ones that do the debugging. They do a lot of some heavy lifting, but to be honest, they're just one member of the team. And then you also need DevOps. DevOps engineer, these are the guys that will manage your CI/CD pipeline. They build the tools, they make sure everything is working. You can go from commit to production. You need this kind of skill set. And also, you need a system architect. Mostly these are people that have been in the game, who have gained some experience. So someone that can architect and say, this is how we're going to develop this thing. And you see, most of these, they are technical skills. But you see, you don't just need technical skills. Please, the next slide. These are the non-technical roles. You don't need to be a coder to be in the team. We have QE, quality assurance engineers. If you don't have a QE in your team, that's I'm trying to find an analogy for this. It's almost like the way we say it's like you're sleeping with fire in the roof. Eh? You need a QE. Somebody their whole focus is to find bugs. Whenever you commit your code, you say it's ready. Somebody else sit down and say, I need to find. And there are people that are special in this area. I love working with a good QE. They look for that mistake. If they don't find one, they don't sleep. They're looking for that bug. And it's good because what it means is that by the time that thing is ready. Then we have business analysts. These are people who their job is to make sure that what you say you are trying to build, they write the requirements to make sure that the developers know exactly what is required of them. And they become your interface between the team and stakeholders. Then you have product owners. You might think, oh, PA and product owner, they're not the same thing. Product owner perspective is in the products. BA is more in terms of delivery of features. Yeah, but they share similar role, but from two different scopes. Okay? Then you have project managers. These are people who just focus on resources, making sure that everything is running accordingly, and we're within budget, and we're also able to meet the deadline. Then you have Scrum Masters. These are people who they liaise with the team. Their own job is to make sure that we're following the agile principles, and they are mostly used also as facilitators. So if they're blockers, they tend to help. So they help to keep the team. So as you can see, to be in this industry, it doesn't have to be that you are a coder. There are other avenues by which you can engage. Next slide, and I'll be rounding up. So, embrace. Let's just go to the next slide, and I'll conclude on that. So the conclusion is this. You need to ensure that you embrace a lifelong learning system. You are always learning. I don't know, I can't help it. I'm always looking at the next technology. What's coming next? Because I don't want it to catch me while I'm napping. Yeah? So you need to embrace this. And embrace this learning, lifelong learning. And then you need to, adaptation is key. I'm learning so that I can adapt in the future. Whatever way they're taking it, I can adapt myself. Also, to provide solutions is all adaptability as well. And then finally, prioritize fundamentals. If you don't know the fundamentals, go back. It's never too late. You might be writing code for years, but I've given you some very key parameters. You need to go to fundamentals. And on that note, I just want to say thank you very much for listening.
Engineer. I've learned a lot.